I just want to explain briefly about the headlight options we have on the Tiger. I made a setup here with a test battery so I can show you the lights. It's already hooked on and just need to get the plus in there to close the circuit, but that's for in a couple of minutes. The problem with the Tiger, with the original one, a lot of people complained about the light. I had the same. I drove this thing in the middle of the night somewhere without street lights, and I had to slow down 30 kilometers an hour. It was mountainous region, it was really dangerous. Shortly after, I had a crash with the bike, not related to the light, related to stupidity. But in any case, I bought a donor bike. This had this one installed. So it's been going for 13 years now. This is a good system. This is a little bit of a dated system, but it is an option. Depending on what brand you will have, you will variate in price. Mine doesn't have a brand, only a patent number. It's Japanese. It's from the beginning, I think. I don't know, it's from a long time ago. But it's strange, there's no brand on it. But in any case, you also have an LED option. LED is, I would say, very good as well, because the lens is perfectly fine. It's just the halogen bulb, but you connect here, you put it in there, and it's not enough. With this, trust me, I can see 50 meters, 60 meters in the dark. With the auxiliary lights, even further. So there's no option, I can just drive normal speeds without any problems. Instead of changing the whole case, what you can do, it's a big expense. You go to the Tiger, to the Triumph website, you just order the case of the Tiger Sport. Some people of you have done this. I think it looked nice, but this is also a possibility. I will try, and later on I will show you how it is actually on the road. Yeah, if I have a camera on the bike, I'm planning on buying one and show you some stuff. In any case, now I just want to show you how this light works. You have three components, and here you can notice you get 12 volts from the system. It goes into the ballast. The ballast is the brain, the controller. It gives an output of 6 amps and about 16 volts. But then this is your igniter. This will send in a big chunk, 2300 volts, 2.3 kilovolts, here into your light. Your light is a chemical, it's a xenon light. Xenon light is ultraviolet. It is a gas system in a ceramic bulb, and there are also some metal salts in there. These metal salts will migrate when they are exposed to electricity. So it comes in here, you have 2 electrons, tungsten, positive, negative. The moment they get the arcing, they get the spark, which this box will do, zip, it gets enlarged, the voltage. There's more tension on it. You get ionization. Ionization is just that your electrons start to migrate and attach to another element. There are different types of there, magnesium and all that stuff in that ceramic bulb. And that will give light. Depending on how this thing is programmed, has been designated, has been designed. Mine gives 8000 kelvins. Normal sunlight would be around 5800, what they say. And you have also 3000 on 12,000, which is purplish, 3000 is yellowish. I think it's not always legal, you have to check in your country. Here in Belgium they don't really care, but I know it's not really legal. That's something you have to take in consideration. I'd rather pay a fine when it happens. I just put a halogen bulb in there, I let them check it out. Afterwards I just put it back in, I pay the fine. At least I'm visible on the road. This is not advice, it's just the way I do it. Yeah, that's about it, I guess. Yes, that's it. I'm just gonna show you now. If I put it on the battery, they are polarized, so if you swap it, be careful, because some guy, red is minus and black is positive. Yeah, it's what it is. You're gonna have your cables melted. But like this, you can see, need some time to warm up and then it's very bright. The problem I have with this is that on the bike there is an issue. I've been working on it, now it's fine. Just I'm gonna explain you also what I've been doing on the bike. Just this is I hope this helps you make a decision. Nowadays the downside with LED is you have to drill a hole in here, because LED, they work with a cooling fan, and you have to be sure that it fits in here and that you normally have the room for the fan. And then you have to of course drill a hole so it can suck air, which of course you will have water in there. So this is for me a downside. Or you have to make some kind of grommet or plastic in there so you don't have that problem. Yeah. That's why I think this is also a good possibility. All right, I just want to go through some electrical troubleshooting. I've been working on the tire, had a problem with the headlight, and still doesn't work. It's intermittent. So this is your daylight. Yeah, it's just not working. The I-beam itself, no issues at all. This is a high intensity discharge. The other one, I explain also how it works in this video, but I ordered some new bulbs. Let's see what happens. If not, it's probably the ballast itself. In relation to that, I have been troubleshooting the bike for a couple of hours, yeah. And I just want to show you some basics. In relation to the light, the issue started last year. This is the relay for the ignition, and also the light is connected with this one. Also the fuse box, of course. But the garage, when I bought the bike 13 years ago, the GPS, they took the power on the light, on the cable. It snapped straight off after, for corroding. You can imagine there's water coming in here. It was not really the smartest solution, but in any case, I solved it and now it came back. So the first thing I did was checking this one, it was okay. And then I came actually to this. This is a wiring diagram from a Haynes manual. It don't matter from which manual, the OEM, another one. For me, this is actually the guide. You have to be sure you take the right one. There's, in these books, but this is the correct one. And you also have to be critical. Yes, because there are sometimes, and also in this case, there are mistakes. In this case, the mistake is color oriented. The directions seemed fine. If you want to start digging into these schematics, I'm going to give you a tip. The first thing I do is single line thinking. What I mean by that, since I know the circuit, single line is, okay, this connector here is the first point. Check the headlight itself, the integrity, the cables inside, it gets 12 volts, okay. Here, that's your first point. Don't matter how much cables you have, 4 or 5. At this moment, just think single line. From here, it goes to here. From here, there's a wire going to the fuse. There's a wire going to the solenoid valve. There's also a wire going to the left-hand handlebar, which then, with this connector, connects here, and there's also a wire going to the ignition. So 1, 2, 3, 4, 5, 6. These 6 points you can write. You can just make your own schematic and write it or draw it, whatever, to make yourself comfortable with that. And after that, you start with the neutrals. I always check the neutrals first because sometimes neutral mistakes happen and you want to be sure and take it out of the way. Electrical troubleshooting is not looking for the mistake. It's taking away the possibilities. For a lack of translation, that's the best way I can say it, but you just try and look at what isn't the case, right? That's another way of thinking. But here, this is a common ground. So you see multiple wires coming in, and if there's one there, you can try and wiggle it. If there's one there, then you'll know straight away. You can measure this with a multimeter, of course. Continuity readings, you can actually go between the chassis and all the neutrals you find and verify on that place as well if it's a good ground or not. Secondly, you should also check your 12 volts or 5 volts or whatever it is, but in this case it's 12 volts. And here you can just follow the wire, and as you see it can go to the start relay, the blue and red. From there you can also see one going to the starter solenoid. And here there's actually a brown one. It's going to go back to the ignition switch, and also the blue and the yellow one. It's also going to go to the starter relay. The fuse box, starter relay. So you check the fuse first, of course. And one of the first things you should do. You can check the relay. You should just swap it or you measure it out. Also an important step. And then you can also say, okay, which wires are going to come here? Ah, that's the blue one, right? The blue one. So this is a central point in this. There is also a feed here and it will go to the ECU, but that's not important for now. Here, this always is a terminal. There's always a connector, something like this. And then you measure it out. You go measure from here. You'll notice this is the blue and yellow. This is the brown one. Here there will be a blue one somewhere. Yes. It goes into the black one. So you measure from here to here. And that's it. You check the connections. You go more into detail. In the end, if everything checks out and it still doesn't work, you have to think about the component itself, maybe that's broken. There is also a way to check a component in itself, to measure out like the stator or the rectifier or the battery. These are complete different measurements that you can just look it up online. I make my own notebooks about this, so I keep this, so I know this. An aide-memoire, we call it, something you can do about your bike or just general techniques, because if you're not a professional, you don't use it every week, you're gonna forget this. And then also a very important topic here is cable management. Like I said before, because the guy he just soldered or welded the wire in here, I had a problem. I actually had a problem on the road, so that wasn't good. You have to prevent this. So you do this by, like I do, everything that I had on the bike, heated grips, battery management system, auxiliary lights, USB charger, whatever the case that you want to add, your own phone, it don't matter, GPS, you put everything where it is, you make it nice and tight, not too tight, because a cable needs movement. Your terminals cannot be forced because you're just gonna snap them off over time. Not too much tension on them, and then you make it nice and tight. I use a different cable, the original one, and this is the one with the wrap I made myself. And that's for the simple reason that everything is protected. Bundle. A bundle is stronger than a thin wire. Huh? So take this in consideration. Sometimes there's no other choice. This is for the auxiliary. I was running out of black tape, so I used yellow. But it won't hit anything, okay? It's protected. against rubbing and pulling and stretching. Okay, hope this helps. These are some basics that you should always take in consideration and just practice. Just quickly want to give you an intake about the multimeter. This is one that has a lot of options. Although it was not too expensive 6-7 years ago, it is not a fluke, but it has a lot of additional options. It's a root mean square, but that's not important for motorcycle. That's just more for electronics. It takes just in consideration the sine wave and the peak voltage or not, and it can, through RMS, will give you the actual value, while average will give you an average. You have, of course, multiple possibilities on this one, and the first one here is voltage. It's pretty obvious. Voltage is just the tension over the system which pushes the electrons and actually pushes the magnetic field, you could say. The moment you have a magnetic field being created, then the voltage is the push of the electrons. Yeah. This is all in relation to what of ohm, of course. You will have EC and DC. Here you also have resistance and continuity. They're both the same. The difference is that you in ohms you're going to have a more precise reading, and you could say continuity is yes or no reading. Beep yes, no beep no. You have to take in consideration that you have to remove the voltage from the system, so you have to disconnect the battery or push a switch before you can actually use it. Why? The multimeter gives already a small voltage to to read what resistance is over it or for it. If you put 12 volts over it, you're going to have a bad reading, or worse, destroy your multimeter. It does the same with a diode. It will push 0.6 voltage on the anode, and then of course when this is forward biased, it will start moving, it will start conducting, and this is how it knows. Capacitor, you have to have like a measurement between 5 and 10% of what's stated on the capacitor, and you have to make sure that the capacitor is disconnected, and then you have to use your probes. Hertz, well, hertz is just the speed of the electricity. You just put it into somewhere and you can measure 50 or 60 or other type of hertz. Like with a motor with frequency, when you have different frequencies, or what is it? I forgot about it. Variable frequencies, that can be useful. Capacity, Celsius and Fahrenheit, it speaks for itself. You need a special probe for this. Non-contact voltage, you can just use this probe and give the initial feel, or the multimeter will say yes or no voltage, and then you can use the designated voltage, so you know more, you know the detail, how much it is. And then you have microamps, milliamps and amperage, also AC/DC. An important step is to buy a better multimeter. I have a light, this is REL, which means relation between multiple readings. You just, when you have a reading, you push it and it will calculate the difference between the two, basically. The range is just so you can set between hundreds and tenths. Voila. This is the normal one. 1,000, 100, a tenth. Max, minimum, just remember the maximum, and then, or the minimum, and hold to keep the light. Yeah. If you buy a fluke, you will be better off, of course, but it's not worth it for DIY. This amp probe, really good for what it's been costing me. Solid case, you have a nice clip for standing up, and it has a fuse. So when you measure amperage, it's important, you always start with the highest. The moment you know you're not crossing the lowest, you can use the lowest. You can play with your settings here as well to help. Also an important one is, I don't know if I already said it, ohms. You don't put any power on the system. Voltage, be careful. But voltage in itself is not dangerous, but you're measuring maybe 5 volts, 12 volts. Yeah, you use the probes. Voila, that gives a little bit of basics on how this works. As ever, you're working with electricity, just be careful. Hereby I also want to show you the relay. The relay is an electromagnetic switch with a coil and just a switch, a magnet, which will actually actuate another circuit or switches between two circuits or amplifies a circuit. It's an old-fashioned system. It is very well, a very good system, but it's a mechanical system, so it's used in systems that don't need to switch 100 times a second. Yeah, then you will use transistors or some other sort of semiconductor. However, for the thing that it's used for actuating the solenoid, it is a very good system. These one, if you buy a good one, they can go a long time. The best way to troubleshoot is you just take another one, you plug it in. If it works, okay. If it doesn't work, then you know the problem is not related to this. That's what we did when we had a supply of relays. Yeah, I don't always have those, so there is also a way to measure with voltage. I'm not going to do this now because I don't have the facility to put voltage over the system and measure. So I'm going to do the ohms reading and the continuity reading. First, you should understand there are 5 numbers: 30, 85, 86, 87, and 87A. 30 is just you have to see as your feet, your power. 85, 86 is the coil, and 87 and 87A are the switch on and off. This one is a normal closed one. 87A and 30 is connected, so the thing is not working. The moment you're going to actuate, it's going to connect 87, it's going to switch to 87, and it's going to align the coil, and you're going to have the switching of the system. To test it, you have 2 ways, or 3 ways, sorry. Continuity between the switch. So you should have continuity between 87A and 30, right? If my theory is correct. And you should not have it between 87 and 30. If you have this as well, or it's not correct, then you have to check, of course, the schematic. If you have a normal open one, then it should be the other way around. But now just know 30, 87, nothing. Okay, that's the way you want it. Now you want to measure the resistance of the coil. If the coil is burnt, then you're going to have another reading. Usually a very high reading. Here you want a reading, depending on the standard is, I think, about 200 ohms maximum. So we're just gonna ohms. So you measure these two. Let's see what it reads. That's fairly okay. I think 50 is the minimum, 200 is the maximum. So it's more on the low side, but this is a good thing. It means there's not too much resistance, so it will work easily. That's what you want. I would say if you have 195, I would say you have to swap it. Yeah, there will be some burning marks in there. And then I think you can also do a reading and resistance between 30 and 87A, of course, because that would also give, just give me a second, here we go, ohms. Between 30 and 87A, you want a reading of no resistance because you have continuity. Here we go. And this should be over the limit, the normal, because there is no connection. Voila, this is how you test the relay. Like I say, best way is swap it. The other way, just some tips. And yeah, let's crack on. Alright, let's say I want to measure another part of the system. I'm going to use continuity. Yeah. What I want to read now is the connection between the starter relay and the starter solenoid. The white or red one. Thing is, it could be another color, but in this case I know it is a red and white one. You can see it straight on here, so you're going to look for the cable. Don't pull too much on the cables. Here we go. I know it's interconnected. This is okay. Same, I just want to know here about one of the wires with the ignition. So I'm just going to go, like I explained you in the beginning, the circuit, I'm just going to tap it off. Yeah. Just want to know the blue, yellow one now. So the next reading, I just want to check between the ignition cable and the relay, ignition relay. So what's possible? Well, let's see. Here we go. Let's check the integrity of the wire. Diode checking, we don't need that. Ohms should be fairly zero. Huh? It's still on continuity, excuse me. Range, ohms. One important step, you first need to check what is your fault on your meter. It takes some time, 0 to 0.1, yeah. It goes a little bit up because it keeps, the longer I hold it, maybe it can, you know, deviate. So 0.1, 0.2 is the fault. So if you see it going up and down in the readings, that's normal. When I do the actual readings, it goes between 0 and 0.1, that's okay. The better the meter is, the smaller the mistake. This is something Amprobe, cost me 100 euros. It's been serving me for 10 years. I love it, but it's not the best. But for DIY, it's more than enough. Another thing I'm going to show you. So I've been checking, this one is okay. So I know the connection between the relay of the ignition, the starter solenoid, and the ignition is okay. Of course, in reality I was checking way more wiring, but it's just, this is a general explanation. Here I'm just going to check. You can use a crocodile clamp. So there is a cable here, the blue one, which also connects to the ignition. Yeah, and from there on it's going to connect to the high beam. I want to verify this. So I connect one here. I know the blue one is okay because I already measured it. And now I just want to verify state. Just going to put it back in continuity. It's working. I can test the switch as well. Off, on. You know, now you know the switch is okay if you want to test the switch. This is also an important step. I've actually been going way deeper. I've been checking everything, the indicators and all, but everything worked out. in the end it was just, it's the light itself. All right, finally, just want to show you voltage reading, small tip. This one here, you can just use a needle in your terminal. Sometimes it's very hard to reach, or you have to go from this side. Sometimes, you see, you can put this one in, and then you could be able to take a reading. Yeah, try it. You put on your voltmeter on DC, put your range in the middle or something. Here you can read hundredths of a volt. It's fairly fine readings, and you can just measure. Of course now it won't work. Why? This thing only works, the ignition on. Here we go at 12 volts. That also tells you how far the battery is. Yeah, I need to charge it. So yeah, this is also a tip. Yeah, you can also work like this. .4. No minus and minuses, because plus is minus, minus is plus. That's okay. In this part I want to go over this thing. A Thunderbox. The type is Tango Bravo Uniform 02, where the difference lays in the quantity of connectors or connections you have, so the terminals. For the rest it's just the same on the one. But first I just want to zoom out a bit on the system. You know, the Tiger, I actually changed the alternator for an upgrade. It also has 18 coils, which is the same as the standard, but it's just a better quality of calibration, which will actually reduces internal resistance, probably the magnetic field, you know, a little bit more efficient, and depending on the flux and all that stuff. So that's the times that the electromagnetic field passes a certain wire will also, you know, just be a little bit better. So, you know, I changed that one, and then I also changed this one for a MOSFET. This is your regulator. A MOSFET is just metal oxide transistors. There is a metal layer in between where everything is doped. It's can deal with higher temperatures, and the transistors inside, they just switch a bit faster. And from there on, the battery is also updated. You can see I have 12 ampere hours and 200 cold cranking amps. Theoretically, this thing is just a little bit more punch. The wires itself is now a 6mm. This is going to the starter, 6 instead of a 4mm. And this, of course, all in all, will already gives a more efficient system. This is, of course, a counter for all my auxiliaries. From this one, this is the heated grips, to my GPS, to my battery monitoring system, to my auxiliary lights. I mean, I think there's 6 or 7 in total. Also an MP3 charger. So all these things, they draw power on the system. And that's for me a reason why the system can have failures. Standard, we know that there are problems because the standard Tiger system is not built, I would say, for all that stuff that I added into the bike. Anyway, there is where this thing comes to play. I just want to say that, just going to the notes. So yeah, I just want to also mention that you know that the Tiger, when you switch it on, and it's just going to draw 3 amps from the bike. So from the battery, because the engine is not running means everything is tapped from this. This is your tank of electricity. 3 amps. All that additional stuff I have installed is another 5 to 7 amps, I would say. That's a theoretical guess because I didn't measure it, but for say 10 amps. If you do that for 20, 30 seconds, this thing is losing power fast. Added to that, when you start the bike, you get a peak to the system because it has to deliver instantly a lot of juice. This puts wear on the battery. Of course, a better system, and if I can use an analogy for water, you can see this as your water pump. This is a valve that goes between 2 circuits, and this is the tank, and this is another valve, but a valve that opens under pressure. So for say, this one actually shunts. For say if it's water, this gives 20 liters a minute. This is one of 200 liters. So after 10 minutes, this one will be full. Excuse me, just pushing some bolts. Well, this one, when this one is full, we'll say this one is 200 liters because for say this one takes only 20 liters a minute. When this one is full, this one is full, this one will dump the excess water back. Well, in real life, electricity will be pushed through the ground. Yeah, so it shunts between 1,000 times a second. There are semiconductors in there, transistors, they switch very fast. So yeah, a part of also, when it comes here, it will convert to DC and then will send actually the power to the coils, to here. So you have actually your spark plugs working. That doesn't come from the battery. It only works when the engine is running, right? Okay, so if you think about that analogy, it just helps you understand how the electricity works. Now, if you also take in consideration that all these numbers are theoretically, yeah, 200 cold cranking amps, that's for a perfect battery in perfect conditions, new state. 2 years later, -5, and didn't run for I would say 4 weeks, which is realistic. It's not going to give 200 cold cranking amps. Yeah. That started the same, 55 amps to get it started theoretically. There's more temperature. I mean, less temperature, it's colder or it's too hot. You're going to use more power. Everything that can help reducing the initial peaks on the system, it is an addition. It is a very good addition. And now I can go to the Thunderbox. So this thing has actually three modes installed. It also has, it says automatic, which is actually true. It has an overcurrent protection, which is also true. This means since it's a semiconductor and you have a surge through the system, and this can happen because a component goes bad or a component gives a bad feedback, whatever, something goes wrong, this will switch very fast and protects everything that's been latched to it. When it is actually monitoring this 3 times, it goes into safe mode. Yeah, you can then bypass this. You have 2 ways to bypass it. One is, well, you just switch it off, and that you do with the white wire, you can see, which is now here. You put this into the negative and it will shut down the system. The second one is, it will still operate, but you draw a system from a 12-volt reference, this one. This is from the backlight. If you switch it in here, you're gonna have one of the 3 modes activated, and that's the ignition mode, which means everything will start working the moment you switch on the bike. Bear in mind, this is designed to put a delay on the auxiliary system. This is how the semiconductor works. So this is a thyristor. I've been looking into it. What could it be, right? I came because they don't share it on Heeltech, and because of my experience and knowledge in electronics, 99% sure it is a thyristor. Thyristor is a semiconductor rectifier. So this is basically solid state, so no moving components, which means it is doped in certain materials and chemicals, so it will, depending on the signal it gets, will let power pass or not. And the signal is pretty simple. It could be the ignition, like I told you, this one here, or the battery giving 14.4 volts. On the symbol that I will show you, you can see that you have 14.4, you have an anode, a cathode, and a gate. The anode, basically when it's forward biased, latched like it is now, plus minus, then it is actually in a guard state. It uses 1 milliamp of power just as it is now blinking. The moment the battery starts working and it gives 14.4 volts, the gate will send a signal, and that means the forward bias current, which is in front of the door, the gate opens the door and it can flow. So everything will start working the moment the engine runs at 100% capacity. The measurement, like I said, is, or that decision is based on power on the battery. Now, when you switch it off, it's also important. This thing keeps on working. It's also one of its strengths. The forward biased or the gate is still active, and what they state on Thunderbox itself is that the holding current, the threshold, is 12.8. So in practice, what does this mean? Well, you actually use the bike and you come back from a gas stop, drink coffee, you come back and everything is still working. Your lights and all that stuff. I think that was weird. That's why I dived into this system. I want to understand why this happened. And that's because the battery is still not on 12.8, it's maybe on 13. So it keeps on giving the power. It can also be a good thing. You switch off the bike and you're in a dark street and your auxiliary lights will still work because the battery will be draining and over time it will switch off. So it's a very, I think I like this. Actually, I'm not sponsored by them. I use this now for the second year. And one of the reasons I also have it is these spring-loaded clips. All my auxiliaries are here. They're in a wrap and then they come here and then they go to the battery. They're protected from surging and they only start working after time. For me, standard, it is in automatic mode. That's what I just explained. 14.4 volts on the battery and zip, after the gizmos starts working. Let me see if I forgot something. Yeah, I think that's about it. And that was it. I hope you got something from this video. I know there's some really, there's some basics, but I thought I'd just take this moment to actually share something about this. Because the troubleshooting itself, like I said, it is very hard to film, it's very boring, but you know, maybe you got something from it, and then for me, makes it all worth to try and do this again, especially for this video. Just some general thing I just want to mention as well of the diagram. For instance, if you have an issue, the first thing you should look at is the neutral. The second thing you should look at is the feed. And I just want to mention here on the ECM, you can imagine all these sensors are connected point to point, and this thing is grounded. So all these sensors are grounded via the ECU. And that's something that you should know. If you have a sensor problem and you start troubleshooting the sensor and everything checks out, well, you have to think a little bit further. Yeah. This is also an important one, the alarm connector. You have to be sure that this one is not corroded. If the thing starts to corrode, you should actually put some dielectric grease on this, not too much, or isolate it from the elements. for me, it is actually used for the indicator, the gear indicator is connected on this one, so it is protected, but be mindful of that. On the other hand as well, the feed of your ECU, I'm going to tell you straight away, is here. Yeah, if number 4 and number 6 goes all the way back to the starter switch. The moment this one is bridged, so that means your engine's running, all these things start to move. Yeah. When you have a problem with the ECU, that's another thing that you should look at. Yeah, this relay. Yeah, important. All right, that was a final tip. Thanks for being here. Really appreciate it. I also think that I'm happy that I can share a little bit of the Tiger again. And yeah, I see you guys in the next video. And I hope it's gonna be the brakes or the suspension, because both need to be done. Well, maybe the valve, because needs to be done as well. I need to order some shims. So yeah, next video coming in soon, and take care guys, bye.